Hello, this is my follow-up to my Gradle intro video, where I'm going to do some live Gradle coding and kind of walk you through some of the basics of Gradle and some not so basics, and kind of introduce briefly many of the techniques you'll use when developing a modern Gradle build. Still, can't touch on everything. Just disclaimer, Gradle's too big for that. But we'll do a bunch of stuff. So what are we going to do? This is loosely based on some work I did with Gradle before. We're basically going to develop a custom plugin that lets Gradle run some Ruby scripts as part of the Gradle build. That being said, this video is really not Ruby specific. If you know nothing about Ruby or you don't give a shit about Ruby, that's fine. We're really just using this as an exercise to make Gradle do something that it really is not good at doing out of the box. That's kind of the whole point. So again, don't worry about it. I'll walk you through everything you need to know about Ruby. So in particular, let me just kind of actually open up like an outline. What we're going to do here is, like I said, we just want to run a Ruby script, but we're going to do it in a slightly more sophisticated way that you would do with maybe a more realistic project that's using a scripting language like Ruby as part of its build process. So in particular, we're going to assume that Ruby is installed already. We're just going to assume that that's out of scope. Potentially, there could be a way to make Gradle do like package management to make sure that Gradle is actually available, but that sounds kind of crazy, too crazy. So let's just say Ruby is already available on the machine that needs to use it, and we already have Gradle available as well. So I guess like Gradle is installed, maybe that goes without saying, but you need Gradle installed if you're doing a Gradle build. And then we want it to run some Ruby, but in particular what we're going to do is we're going to use a Ruby dependency manager called Bundler. So that will let us install like specific versions of Ruby libraries, which will be useful because this way like you can actually do sophisticated stuff in Ruby. You can install like all these third-party libraries to do like advanced Ruby stuff as part of your Gradle build if you want. That'll also be a more interesting example. And then we're gonna encapsulate all of the Ruby stuff in a plugin for Gradle, and then our Gradle project will set up that plugin. That's basically the goal. So our Gradle project itself is going to do almost nothing. Most of this video is just about how you would set up that plugin, because that's where we're really going to start monkeying around with a lot of like the more like internal Gradle stuff, the advanced like modern Gradle techniques. And it should be easy at the end of this for you to see how you can apply these patterns to basically anything you would want to do. Though, again, not everything, because I can't cover everything. So you're going to definitely have to look up some stuff for yourself after this, but this should give you an idea. So in particular, how to run Ruby. And this is not Gradle specific, and again, don't worry about the details. These are just like the steps as a reminder of what we're going to do. So first we need to configure Bundler to install dependencies in our build folder. Basically because like these dependencies shouldn't be like, we don't want them like checked into our version control software, for example. So we want them to be, I should say, in our Gradle build folder. And then once we do that, specify which dependencies we need, and then download dependencies if needed. And bundler can handle, like, if the dependencies are already available, it won't reinstall them, so we don't have to do anything fancy there. Bundler will handle that for us. And then run a Ruby script from within a Gradle task. That's specifically what we're going to try to accomplish. And I also will just, one last disclaimer before we jump in. This isn't going to be like super proper Gradle code. Like, if you wanted to develop like an official, not an official, but like a more professional third-party plugin that you would like publish on the Gradle plugin repository for other people to use, probably there's much more involved in that. I'm not familiar with that. This is more of like if you're developing like an internal plugin just for your own use or for your own team's use, something that can be much more specialized to like just the task that you need it to accomplish. That's what I'm targeting today. General like open source plugin development, I don't know about that, so I'm not going to speak to that at all. Yeah. So that's like our outline. I don't know.
Here's what I found.
I'll just save that, and we'll hope that that's good enough. Sorry for Siri interrupting there. But so yeah, and so you can see right now I have literally an empty directory. I have this .idea folder. That's just a temporary thing because I also had my IDE open this. I'm using Android Studio. This isn't an Android project just because that happens to be what I have around that understands Gradle. So that is like my first recommended step. Whatever editor you're using to follow along with me here, it's got to be something that like has Gradle functionality built into it. So like IntelliJ, which Android Studio is based on, I know does that. I really don't know what else is out there, but the crucial thing here is you absolutely need autocomplete. If your editor cannot autocomplete stuff while you're writing Gradle scripts, this is going to be extremely difficult for you. So that's why I'm using Android Studio. So the other thing that we're going to do, so once you have your editor and your editor has like a Gradle plugin to, you know, do syntax highlighting and stuff like that, we're going to use the Gradle wrapper. So I have Gradle installed. Let's see, Gradle 8.1.1. And the important thing we want the wrapper for is to give us some stability. So even though Gradle is fairly stable, they love to break stuff between every single release. So even like a minor version update might break your build potentially. And so their fix for that, really their workaround for that, is use the Gradle wrapper to have a reliable version of Gradle that you're using for your project. It's like the Gradle version is tied to your project. So what we can do is just run Gradle wrapper, and that's going to try to initialize the wrapper, but that's going to fail, which is fine. And it even tells us why. A Gradle build should contain settings.gradle, which if you watched my last video makes perfect sense because that's what defines a Gradle build. So right now it's like, are you even using Gradle, dude? So we can do that. I think if we just make an empty file, it'll be happy. Okay, it would help a lot if I named that file correctly. Settings Gradle KTS. There we go. So now Gradle's happy. It believes that this is a Gradle build. And so just the fact, again, we created an empty file here. So just the fact that that settings.gradle file exists, it is perfectly happy. And so now we have a bunch of stuff. You can see that it's created a Gradle directory, a .gradle directory, and these two Gradle W files. And briefly what these are, so .gradle is all temporary files, so you should like ignore this if you're using version control. Gradle contains some interesting stuff. So we have this whole wrapper directory, and so in particular it has a jar which actually contains the wrapper code. And so I feel weird about it, but that's what you're supposed to do. You commit that jar to your version control. That's what ties the Gradle version to your code, the fact that this jar is available. So like then people don't even need Gradle installed technically to build this because this is available. And then this properties file contains information just about like, okay, what version of Gradle did we get and some configuration options. So that sets up the wrapper. And then now that you have the wrapper available, basically we're not going to run Gradle anymore. That's forbidden. We're always going to use Gradle W. And so that ensures that you're using the version of Gradle that's been bundled with this code. And other than that, Gradle W works exactly the same as Gradle. If you're on Windows, use the bat version. All right, so now we have that. Let's actually get started doing some Gradle stuff. And the first thing we're going to do is start at the top level, which is our root project. So I'm going to switch over here, and we're going to make a file. So this is going to be, actually, we don't even need to make a file. I already made the file. We just have to fill it in. Here we go. So settings.gradle. And what we're going to do in here is just, I don't even know if it's important, but it's a good idea to set your root project name. And so I'm just going to call this like Gradle example. And then we're also going to set up custom plugins. That's like the main thing we want to do. So we need a plugin management block. Actually, I wonder, related Gradle project not linked. I wonder if I just sync now. This is one of the annoying things of working with Gradle. Because Gradle is so configurable, it like has this incredible plugin system that can change any aspect of it. It does make it a little tricky for your IDE to work with it, because while you're editing Gradle files, you're like potentially fundamentally changing how Gradle itself is working. And so here, like my editor was complaining that like it didn't have enough information to even do syntax highlighting or autocomplete. So that's why everything was just showing up as white. So at least in Android Studio, I think IntelliJ works the same way. Every time you make changes to a Gradle related file, you may have to tell the IDE to sync, so that basically say like, okay, try to understand how my build is working again so that I get syntax highlighting back. It's pretty annoying. So syntax highlighting is going to break all the time. I'm going to have to be manually syncing throughout this if I want to be using it. But it seems like that worked, because now the root project name is highlighted, and so we've set that. So this is the name of our overall root project in our root build for Gradle. So hopefully now, there we go. Okay, so autocomplete is working. So we have this plugin management block we can call, and this is one of the most important things you're going to do in your settings.gradle files, because this tells Gradle where can I get plugins from. And so in our case, we're going to include custom plugins, and this is the conventional place where you should always put plugins, Gradle/plugins. I would say for a real Gradle project, you would often do something like repositories.maven central or something to include just like, the common plugins. But in this sort of toy example, we're not even going to do that. We're just mainly screwing around with the custom plugin stuff. So I'm actually going to just get rid of that. We don't need any like, community plugins or anything like that. And then the last thing we're going to do here in terms of like project structure, just to keep things clean, is we're going to have a sub-project, just so that we're not using the root project for everything. So I'm just going to call it like my project, and that's that. So we can already start making some structure to match this. So we need plugins in the Gradle directory. And then also in this directory, we're going to need a my project. And we can start filling some of these things in. So this one in my project, since this is a sub-project, we're going to use build.gradle.kts. Well, maybe I actually want a sub-build, now I think about it. Yeah, maybe that's how I want to do it. Kind of deviating from my script a little bit, but it should be fine. Sure. Hopefully I don't regret this. Okay. So just gonna keep syncing every time it complains. So now we have a sub build, and let's give it a sub project as well. And so now this is sort of its own sub build. And so theoretically, like, this is how we would organize it if you watched my last video. So my project is where we would put all of our quote-unquote real code, like all the stuff we're actually developing on a day-to-day basis. Gradle is where we would put our custom Gradle stuff, all of our custom build code. Settings.gradle then is just for like overall project structure. And then if we wanted to, we could also have a build.gradle.kts at this level, which would be for those lifecycle tasks I talked about, which are just tasks that group together other lower level tasks into convenient groups again. So that's that. And so I think we can do just the same thing here. In this settings.gradle, we're going to include the same plugins, and that should be it. Should be all we need. Yeah, I think that'd do. And then here, I think I'm just going to try to leave this empty for now, maybe. It should be happy with that. So maybe it's kind of hard to pick a starting point here, because since Gradle like wants you to create all these levels of abstractions, like technically the first thing we should do is start immediately diving into the custom plugin and like defining these abstract things so that we can hook them into the build later on. But I think that might be a little bit confusing. So instead, let's just kind of like code as if this will work, and then we can talk about it. So what we want to happen, so again, this is in my project, which is like our real code, in our build script defining that project. What we want to be able to do is say like, let's include a plugin that is custom. So I'm just going to say like, my name is Max, so I'm putting it in that package, and I'm just calling it Ruby. It's our custom Ruby plugin. So I want to be able to do that. And the goal is, this won't work now, but by including that plugin, we should get access to a custom domain-specific language where I can tell it, like, okay, I want to get my gems from here. So gems are what Ruby calls its dependencies. So here we're like providing input to the plugin to say like, okay, when I use Ruby, I want to get my gems from this particular gem repository. So this is a little bit weird. Again, this is like maybe not the nicest way to do it. Like I've seen plugins, because Ruby has like dependencies the same way that like Java has dependencies, there are ways to like write a more proper plugin that would actually incorporate it into, well, I guess I didn't show it yet, but basically where you could actually specify repositories at like the settings level and install Ruby dependencies. That would be the proper way to do it. But again, we're just kind of hacking it in. The goal here is that like we're going to have Gradle just running the commands almost as if it was on the command line. So don't worry too much about like, again, we're not developing like a fancy open source library here. We're just like making Gradle do what we want. And it's really just an example. So this is what we want it to be able to do. This is definitely not going to work yet, though, as I said, because it's red and we haven't even defined this plugin. But that's the goal. So I'm just going to comment that out for now. And so next thing we can do is we can define this plugin. So under Gradle plugins, we defined this as its own build. It is a include build, means this is a Gradle build. So that means we need a settings.gradle file there. And this one's going to look a little bit different because here, now we're actually doing some stuff. So, in particular, okay, always got to sync. Okay, so in particular, in our custom plugin, we're going to be writing a bunch of code. Whenever you're writing a bunch of code, you should have tests. So I'm going to walk you through how to do that. Before we get to the tests, though, we know we're going to have to get some testing dependencies. In particular, Gradle does not know how to test things on its own. So we're going to get JUnit. So come on, autocomplete. You got this. Yeah. So in particular, our custom Gradle plugin will have normal dependencies. It needs to get JUnit in order to test stuff. So here we will actually specify Maven Central. I don't know what this warning in. Okay, no one cares. And then we're going to have subprojects here. So the convention is that for each plugin, custom plugin you're developing, you should have a subproject for each. So we're going to include one, and we're just going to call it Ruby Convention, which is like, this is our plugin for how we do Ruby stuff. And so now that we have that, we need a directory for that subproject. Every subproject gets its own directory, and every subproject is identified by a build.gradle.kts file. And here we're going to do probably a bunch of stuff, because in here is where you're going to specify like all the things that you need in order to build your file, in order to build your plugin, rather. But for now, we can just start off by saying this is a Kotlin DSL plugin, which is the magical type that you use built into Gradle to tell it I am developing a custom Gradle plugin. So if you watched my last talk, I mentioned this there, that in a build.gradle file, when you are applying plugins, the useful way to think about that, like, yes, in a sense, you're just applying plugins, but a useful way to think about that that's reasonably accurate is to say I'm defining the type of Gradle build I'm doing. So this Gradle build is of type Kotlin DSL. Our goal for my project is that this will work, which means we want it to be the case that I can say my build is of type custom Ruby build. That's the goal that we want to get to. We're defining a custom Ruby build as a type of Gradle build. So we're going to do that. And for now, let's leave it at that. I think, again, like this is where we're going to add like testing information when we get to that. And I don't feel like specifying that right now. So yeah, let's forge ahead. We're not going to do like test-driven development because that would be tedious. So we've got that. Now we can actually start defining our plugin. And so this has, we're going to do it in Kotlin, and it has actually a rather traditional structure that I'm going to, sorry, I'm looking at my notes here to make sure I don't mistype anything here. So I'm going to kind of cheat here and use a shortcut. So we know it needs to be source main Kotlin, and I'm just going to give it that name. So source main Kotlin is like the traditional structure for if you've ever done like a Kotlin project before, and that's exactly what you use for a Gradle plugin written in Kotlin, so nothing fancy there. This one I gave it a fake name because it shouldn't actually be called foobar. This is where you put the name that you want to use to include your plugin. So this would be com dot, I think I called it max.ruby, and then you also have to put .gradle.kts at the end. And so that's what tells Gradle, like, this is my script that should be compiled to create my plugin. And just keep syncing. Hopefully Gradle will be happy. And so in here is where all the code we put in here is essentially going to be the code that sort of, in a way, gets like copy pasted into this build.gradle file. So when we include this plugin, everything in here is going to get dropped in there. Everything in the com max Ruby. And so for now, again, I'm going to write code that's not going to work. We know we're going to want to create that domain-specific language. So we can use this built in to Gradle. We can say extensions.create, and this doesn't exist yet, but it's going to create, this is some type that we're going to define, and we're going to call it Ruby. And so this name is the name by which our script will access it. So this is Ruby because this is Ruby, right? And we also get a variable for it because that is what lets us access the extension in this file. So we can, this kind of gives us a, basically an input. Well, I don't know, no, sort of like a pipe so that we can get information into our plugin. So like things that we do in here will affect this Ruby variable. And so we can use this Ruby variable to get access to that information in our custom plugin. And yeah, so I think we can just actually go ahead and try to define that file. So that goes again in the sort of traditional Kotlin structure. This is going to be com max ruby dot ruby extension. And this will be, we'll call it a class, I don't know. So remember, we're in source, main, Kotlin, com max ruby, and then here we have our Ruby extension. And this actually isn't going to be a class. We're going to use an interface, and this is sort of using a shortcut. So Gradle extensions can be very complicated. There's a lot that they can do. So like I said, they can define a whole domain-specific language, and it provides a couple of shortcuts to make that simpler if you don't really need a fully fledged domain-specific language. In particular, if all that your extension needs to do is like, hey, let me define some values in my build script so that your plugin can see those values, all you need is an interface, actually. And so in here, we can define all the values that we want to be able to get. And in particular, for this simple example, we just want to be able to do this, where I'm like setting this gem source value to a string. And so that's all we need here in our Ruby extension. So here I can say gem source is a property of type string. And so we need to import that. I don't know why. One of the annoying things working with Gradle is everything is apparently defined like 40 times. So whenever, like, at least in Android Studio, when you're importing, it's like, which one do you want? And it's usually pretty obvious. You want like the simple one, which in this case is the top one. So that's the type we want. And property is a magical Gradle thing. This is one of the ways in which Gradle does efficient execution of a build. So properties are a way to wrap a value so that it can be lazily fetched, it can be cached, you can kind of hook things up with a property even though the value doesn't necessarily exist yet, which is exactly what we need here, right? Because we want to use that property in this plugin script. But the property, like the value of that property, isn't going to be defined until after our plugin is built, it gets included here, and then we finally set the value. So it's like we need a way to say, like, we need this value before it's ever even set. Properties let us do that. So that's our extension, and that's actually all we need for the extension because Gradle provides this shortcut to do that. So we should actually be able to go back now and grab this. And if we sync, should be happy with us. Yep. So now we've created an extension, and we've created our script. So unless I'm forgetting something, we could actually try, that. We're syncing. We'll see if the editor becomes happy with us. And it does! Amazing! So, yeah, that's that. So, not a lot has happened yet. we really don't have any functionality, but we do have like our project build script, as simple as it is including a custom plugin, and that plugin does have a custom, very simple domain-specific language that lets us pass information to the plugin. So that's all cool. Now, this is one of the goals of Gradle, is to abstract your build process, to simplify your build scripts, and we've sort of already accomplished that, because now that we have this structure in place, this build script for my project doesn't need to become any more complex. All the complexity is going to be hidden away in the custom plugin. So now that we're here, we can use this Ruby value to get the data we need. What kind of stuff do we want to do in here? Well, I can consult our outline again. So we want to do this stuff. We want to like configure bundler to install dependencies. In our build folder, we're going to specify the dependencies we need, download the dependencies, and then we're going to run a Ruby script from within a Gradle task. That's the meat of the project. So in particular, we're going to get a directory where we're going to kind of encapsulate all of our Ruby stuff, just so that we're keeping things kind of tidy. And so you can use Gradle here. So I'm using layout.build directory is built into Gradle. And so this, I can say like, in the directory, wherever we put our temporary build files, make a directory there called Ruby. And again, I'm using a provider just in case that needs to be lazy in some way. Always try to be lazy with Gradle. And that's what we're going to use. And now what we want to do is define a couple of things. And I'm not sure what the clearest way is going to be to do this, because again, like this code isn't going to work as is. We want to be able to do something like tasks.register. We want to create a task that's going to get our dependencies and store them in this directory. So again, this doesn't exist, but it's going to be something like fetch gems, and I'm going to call it, say, like fetch dependencies, maybe. And this is going to be something like working dir. This is probably not even going to work because it's angry at me right now. Yeah. So I'm kind of pseudocoding now. But we can say like gem source. Actually, we don't even need to say gem source. So the idea here is like we want to get our task and we want to configure it. And the way that Gradle likes to do everything, like I said before, is lazy. So the reason why this looks the way it does, why we're not just saying like fetch gems init or new fetch gems or anything like that, is we're more telling Gradle, how do you lazily configure this task? So in this block is where we're putting the configuration that will be run if the task is created. And so we want to be able to do things like tell that task where to put all the Ruby files. We want to be able to pass on the gem source information. So we're going to want to be able to do something like source set Ruby gem source. So like get the gem source from this extension and pass it along. And then we want to be able to specify like gems set, and I don't know, it'd be like a map of like gem name to version. So like some gem to some version, something like that. So that we could specify like a whole series of like, these are the gems we're going to get for our Ruby extension. So sorry to sound like a broken record here, but again, we're not building like a general extension. Remember, when you're building these convention plugins, you're not building general extensions. Don't try to make it general. You're going to go crazy. The whole point of a convention plugin like this is you're saying, this is how my build is doing things. So, even though we're calling this our Ruby convention, our Ruby extension and stuff, like this is really more like what do we need to do with Ruby in our build. So if we're using Ruby, like the example where I've used this professionally is like there are some utilities that are just written in Ruby for like converting file formats or performing specific actions that are useful during a build. We wanted to run those as part of our Gradle build, and so I wrote code like this to basically teach Gradle how to run those Ruby scripts, just because we needed it for our build pipeline. So that's what this kind of style of development is good for. So we shouldn't be too freaked out that I'm like hard coding values here, because it's like these are the Ruby dependencies that we need for our convention of how we're using Ruby. That's what we're doing. So that's the goal of what we want to write. And so since none of that's building, let's maybe try to fill that in right now. And so this can go just right next to our extension. We can make our fetch gems task. And this is going to be a little more involved. So here's where the real fun begins. So first of all, kind of a weird thing, similar to our extension, where all we needed for the extension was an interface, we don't actually need a concrete class. We don't want a concrete class for our task here, because again, Gradle is going to do everything lazily. So the reason why we're defining an abstract class is we're just telling it like what's the general shape of our class, and it's going to use that to create a concrete task instance at runtime. And we never actually need to see what that concrete instance is. And in particular, what we're going to use here is we're going to inherit from a built-in type called exec, which is the type used to just like run shell commands in Gradle. And so that's going to save us a lot of effort that we can just inherit from that and get a lot of functionality for free. Next thing we're going to do is just think about what are the abstract inputs and outputs for fetching gems. And in our case, we're going to have an input for the gem source, where we're downloading dependencies from, and that's the right property. And then we're going to have an input for the actual gems that we want, map property. That's a map from strings to strings. So a couple of things here. So this get input stuff, that's all Gradle fanciness. You need to annotate which things are inputs and outputs, again, so it can do that magical lazy dependency resolution to see like, oh, well, this input is hooked up to that output, and I haven't run that task yet in order to generate the output, so I'm going to run it now. This is what lets it construct the whole dependency graph between your tasks, these annotations here. The other thing to call out with properties is for many types, you can just do property, angle brackets, whatever thing you're wrapping. Gradle does have a bunch of built-in things, more specialized properties, I think mainly just for convenience. I'm not sure if anything would actually break if you just used property with a map inside it, but in this example, I'm using map property. I think, did I use one earlier already? No, I didn't. Okay, yeah, so I think this is the first more specialized one. I know there are ones for like, I think there's special types for like files as well. There's a bunch of them. You can just check them out. And then lastly, we're going to tell Gradle what does our task actually do with the task action annotation. And in this case, we're going to just override the exec action because we want to customize that. And we're going to add a bunch of modifications to that. So in particular, we're going to get our source. So you call get to actually get the value of a property. So this is the actual string value now. And then, okay, we're going to do some nastiness. I'm going to introduce this later. I had this in my notes. Just for testing, this will be more interesting if we actually have something to test. But for now, I'm just going to say, like, this is the name of the command we're running. And then here we want to do that step from the outline, configure bundler to install dependencies in our Gradle build folder. And so what we're going to use for exec, it defines, since this is like the built-in Gradle thing for running stuff like as if you're on the command line. It has the concept of a working directory, and so we're going to use the working directory for that. So we're just going to say this task is going to do all of its stuff in the working directory. Because our plugin defined, we're going to set up that working directory to be this like special Ruby directory. So all of our Ruby commands are going to run in that one shared directory. And so here you can basically just, you're almost like writing like normal Java or Kotlin code. You have access to like all the APIs we do. So I'm just going to say like we have to get our working directory path, and we're going to put a config file there. And don't worry about this too much because this is just, again, kind of like Ruby weirdness. Like this is where you put a local config file for bundler. I'll briefly explain. Bundler, for whatever reason, by default, tries to do like global dependencies for the entire system. We don't want that. We just want dependencies for this particular Gradle build. So we're going to set up a config file to tell it to do that. Maybe there's an easier way to do this, but I don't know it. Oh god, I'm getting a phone call. Okay. Sorry about that. So now we're going to get, in that directory, we're going to create the config file. Ooh. And then, yeah, that looks right. And then here we can say if the bundle config does not exist, we're going to create it. So we create the parent directory if we need it, and then we're just going to write text here. And this is going to be, again, this is just Ruby magic. Don't worry about it. There we go. So this is just creating that config file so that bundler, basically it's going to install all of our dependencies in this bundle thing, and it's going to load our dependencies from there as well. So that nicely encapsulates everything in here. And now what we can do is the next step, probably specify which dependencies we need. So again, kind of hacky, but the way I've decided to do this is like, since we're teaching Gradle how to do all this stuff, how to configure bundler, how to install all of our gems, traditionally you could just like save all these files to the Git repository and have Gradle run the command directly. But just to make it a little more interesting, make the example more sophisticated, I'm encapsulating all that functionality here. So instead it's like, you just tell Gradle directly what you need. Like, I need these gem dependencies installed, and Gradle does everything, like creating all of the files that bundler is going to use to do that. So in particular, I'm going to create the file that actually lists out the dependencies we need now. So same thing we did before, basically, but now it's called the gem file. And we're going to write text to that file, and that's going to be, we specify our gem source. Don't worry about the syntax here, it's Ruby specific, but basically this is the syntax for specifying where you're getting dependencies from. And then here, a little bit nasty, basically what you need to do is it needs to be like gem version, etc. However many dependencies you need. So we're going to just convert our map to that syntax. And I'm just going to do this in an absolutely nasty one-liner that I wrote earlier. So we're going to map our gems to gem I need it dot key, and then we need to close the quotes. All right, yeah, you need gem before each one as well. That's why I'm doing it. It dot value, close the quotes, close those quotes, join to string, separator is a new line. That looks right. So we get the actual map from the property, and then we convert those to gem, key name, value, wrapped in double quotes, joined with new lines. There we go. So that's our gem file. And then we can use a built-in thing. This again comes from exec. We can say command line, and we're going to say bundler install, So it's going to install those dependencies to our working directory, and then superexec will actually run that command line. So this is just specifying what the arguments are. The super.exec is what's running them. One caveat about this that's really stupid is Gradle should really handle this. This doesn't work on Windows. So if you want this to work on Windows, you actually have to I think it's I can't remember the trick. I think you have to specify like that. Just because Windows is stupid. You have to actually change the command line if you're running on Windows, because Windows command line is weird. And you can do an OS check. I don't remember how to do that, but it's something you can say operating system is Windows and modify it accordingly. But we're not going to deal with that for this example because I'm not on Windows, thank God. So that's that. So that should work. Feel good about it. So now let's actually try to get this in place. So now we have fetch gems. Okay. File. What's the freaking syntax here? I think I might have to actually get it. Oh yeah, I have to get it. Get as file. Right. Again, weird because we're being lazy. Actually, there's probably a way I can probably map this. Oh, because I'm setting the working. Sorry, duh. Well, okay, I'll still talk about it just because it's interesting. So again, remember this is lazy initialization. Is lazy initialization. So we have a provider for a directory, and I was thinking oh, working dir needs a file maybe. So the way you would lazily convert a directory to a file object is using map. That lets you lazily map the provider without actually evaluating it. But in this case, working dir doesn't want a provider, it wants the actual directory. So we just want to do get as file, basically saying that okay, when it comes time to configure, we do need the file, not a property anymore. So let's get that directly. And then, oh, everything actually worked. So we need a real gem to get here, and so I wrote down one just as an example, just really stupid. This is a gem that lets you do colors easily when you're printing to the terminal. So just for the purpose of example, I'm going to put that in. And also just to make this a little bit nicer, we're going to group this task, and we're going to say, we're going to give it a description, just because that'll make our output look a little pretty. And that should work. I will, just being a little bit forward thinking, save that in a value, just because, again, we want to reference it in this file, so it'll be convenient to have that. So yeah, and I could run this all from within IntelliJ, but just to kind of show you that it's working. So now what should have happened is, since our plugin has defined a task with a name, and our project has included that plugin, this task should now exist on this plugin. Because again, it's as if everything in here gets copy-pasted into this build script. So, this said define a task, so now this should have a task. And so I'm going to run my project tasks, and hopefully, please don't fail. Okay, excellent. So you can see now we have Ruby tasks, and we have fetch dependencies. Fetch dependencies, which installs gems. And so dependencies. Cool, and so you can see fetching gem metadata, resolving dependencies. We already have bundler installed, that comes with Ruby. Fetching paint, installing paint. Bundle complete, 1 gem file dependency, 2 gems now installed. And so now if I run this again, because it's written everything to our build directory, and bundler is already smart, bundle understands how to cache dependencies, it should see, okay, using Paint, right? We don't need to install it anymore. It's already available. So this task is already running efficiently. And so we've got it. We just taught Gradle how to install Ruby dependencies using Bundler. Pretty cool. So let's continue now. What I really want is this other task to run Ruby. But before we get to that, I'm going to write some convenience code. And again, this is like kind of being silly, but just to, what's the thing? Just to make it more testable, just so we can write some slightly realistic tests later. Yeah, where do I want this? So I'm gonna go to fetch gems, and there's this one thing here about bundle. Now, let's say that this is running as, maybe we have like a continuous integration system that's running, and Bundler could be installed in like a different way on that system. So I'm going to, just for fun, define a way to like look up different possible files that could exist. I don't know. It's just something to test. So let's do that now. So I'm going to make a Kotlin file, and we're just going to call it path lookup. Beautiful. And here I'm just going to make, I don't really need this to be very fancy. I want just a set of paths to look in and a file we're looking for that exists in those paths. And so here I can say, full path equals file, and I guess I should import that normal file stuff. We're going to do path exe if full path exists, return full path absolute path. Oh, I forgot to do a return type. And if all of that fails, we'll just return the exe and hope that it exists in like the whatever default path it happens to be checking. So now that we have that, we can go here to fetch gems, and we can instead say, let's do path lookup bundle, and I actually do have this because I'm using a Ruby version manager that installs Ruby in like alternate locations where I can manage the version of it as it changes. So I'm actually going to get my home directory, and rbnv, I think shims is where it puts it. And so now I'm saying like, first look for bundle in my home directory .rbnv shims, and if that fails, we'll just call bundle and hope that works. So I just changed that. Just recompile. So one nice thing is you can see that, well, maybe you didn't see because it was very fast, but Gradle understands that like our build, this task is dependent on our custom plugin. So every time I change the custom plugin code, it automatically sees that it has to recompile things. You don't have to worry about like it running an outdated version of your plugin. So that's that. And so now what we're going to do is we're going to define this task to actually run the Ruby code. And so here I'm going to make this, and we'll call this like, I guess we'll just call it run Ruby. Sure. Going a little bit off script here again, but hopefully I don't regret it. That's not how you spell that word. So the same thing, we're going to exec this because the goal is that Gradle is going to run Ruby on the command line as if, we were running it ourselves. So we're still just going to use the exec task. And here, let's do an input, which is script. Maybe. Sorry. Perfect. What are you angry about? Property must be oh, right. Sorry. Abstract file. And then here I can do task action. Same deal. Override fun exec. Super exec. Same thing. And so what we're going to do here is file. And here we can actually get a temporary directory. Nice thing from Gradle again that just provides that. I'll just call it temp.rb. And we'll write our script to it. So here the script is like, this isn't a path. That was not my intention. The goal is that we can actually write Ruby directly into what we want it to write, which is write Ruby directly into the task definition, which I think would be pretty interesting. So we're going to do the same thing here. I'm going to be a little bit sloppy. We're going to get bundler, because basically we need bundler. The same thing that installed the dependencies needs to run the script so that it'll find the dependencies. There's probably a more fancy way to do that. You could actually, we could tie these together. Like maybe there'd be an input which provides bundler, and that way we could actually guarantee, we have one thing that gets bundler and then passes it as an input to both tasks. I'll leave that as an exercise. So here we're going to run bundler. We tell bundler to exec Ruby with our script path as input. And so that should actually run our script now. And I'm feeling pretty good about that. So now we can come back here and we can say, we'll call this, I don't know yet. So we'll register a run Ruby task. And we'll call this one something. I don't know. We'll come back to that again. So now we need to give it input, and we'll say script set. And here we just write some Ruby code. So I'm going to try to use that gem just to make sure that it's actually seeing the dependencies. And here I just looked up this silly example. I'll say I'll give it the old hello world, and we'll have it do that in red. And yeah, I like that. So then we'll just call this say hello as the task. Oh yeah, depends on fetch dependencies. That's important, because we need to make sure that if we haven't already fetched dependencies, that this one is going to fetch dependencies. And we should make this a little bit nicer too. So we'll put these in the same group. Why not? Description is going to say hello, and I guess says hello. Do I want anything else in there? I don't think so. Oh, right, no. Most important part here is also set the working directory to make sure that, remember, this is where our dependencies were installed. That would, yeah, it definitely would make sense as an improvement, because it's the working directory plus bundler that ties these together. So it'd be nice to make a common variable, a common dependency that actually ties them together. But again, exercise. So that's that. So now we should see in my project, we have say hello. Hello world in red. Amazing. And so now, just to make it a little more interesting, we should have some build folders here. Yeah, so it's using the cached gems, so I want to make sure that it actually will install those again. Oh, right. Sorry. Clean you don't get by default, which is kind of surprising. Most plugins define a clean task, but we don't have that, so I'm just going to be, I don't know, a little bit more manual about it. And just tell it to delete those directories. So, oh no, I can't. Okay, fine. Excellent. So I've deleted all those build directories. So now there should be no like gems sitting around anymore. And so now if I run this task, it's actually going to do a lot more work for it. It's going to rebuild all the plugin, then fetch the dependencies. And you can see it just reinstalled the dependency because I deleted it. Say hello world. So if I run it again, it's going to be a lot faster because it already had them downloaded. So that's that. And that's basically the full example of like developing a custom plugin. We just taught Gradle how to install Ruby dependencies in the build directory and run Ruby using those dependencies. So now, chapter 2, if you want, is testing. We did just write a ton of code. It's a little bit scary that we haven't actually tested any of it other than just like trying it out in the command line. It would be nice to know that it's not going to break if we were to run it in the future. So let's do that. So in particular, I can show you some of that structure. So I kind of hinted at this before, like we used, this is like a pretty normal structure for a Kotlin-based project, and indeed that applies to tests as well. So just as we have like source main Kotlin, Commax Ruby, we can do source test Kotlin. So here I could do like, well actually, okay, I'm just gonna cheat again. I'm gonna do new Kotlin script, maybe. I don't know if this will work, because I want to do test Kotlin Commax Ruby path lookup test. Bam. Yeah. And then I'm gonna I don't know if there's an easier way to do that. So just as we have source main Kotlin, now we have source test Kotlin. And I want to be able to write a test file in here where I can use like JUnit and everything, you know, foobar, I don't know. So one kind of gotcha here. Well, I don't know. I feel a little bit uncomfortable about this. So as you can see, Gradle does actually have JUnit inside it, but as you can see, it's internal. Maybe that's fine to use, but I feel very uncomfortable with that personally. I'd rather use JUnit properly and like include it as an explicit dependency of my plugin. And it's also just a good exercise to show you how that looks. So for now, we cannot annotate this with test. It won't work because we don't have JUnit available. So let's fix that. And so the place to fix that is in our configuration for this custom plugin, the build for the custom plugin. We need to add JUnit as a dependency. Where do you do that? In the plugin's build script, which is build.gradle in the Ruby convention. So we've got Ruby convention, build.gradle. This is where we're configuring the plugin's build, or rather the plugin project. And so what we're going to do here now is first we can hook into our tasks that already might exist and say those are gonna use JUnit. And I think that JUnit, sorry, is JUnit platform? I think that's what it is. Yeah. So this is, yeah, I think this is built into Gradle because of kind of what the comments are saying here, that like, because of like configuration being possible with different runtime test engines, like you need a way to tell Gradle about that. I don't really understand. There's another thing that's not great about Gradle. Every now and then there's just like, and here's where you put in the random thing to make it work. But this whole like tasks with type test thing, this is actually like a fairly useful tool. This is like a common way to modify existing tasks that like might be defined in other places. And if you saw my last video, there's quite a lot of examples of that in the idiomatic Gradle repository. And what we're going to do here is we're going to just add our dependencies. So if you've done Kotlin or Java development, this will look very familiar to you because it has this idea of every source set gets a corresponding set of functions that are usable in the dependencies block. And it works the same way with the Kotlin DSL plugin. So since we have a test source set, we have this test implementation thing that we can call. And then if you've read like the JUnit docs, there's just a JUnit specific thing. We need the JUnit engine. I think that's right. Org JUnit vintage. Yeah, I think that's right. And yeah, that lets us do that. Yeah, that should be good. I think so. And so now if we sync, now it should see that we actually have JUnit available in this source set. Bam. So now we can just import JUnit directly. We don't have to use Gradle's internal JUnit version. I don't really feel like going through writing a unit test here, but just like to show you, you can write all your normal JUnit tests in here. Just to make this a little bit nicer, what we should do is we should go in. Well, actually, no, it should already. Yeah, let's So we have plugins, right? And so it already has a check task. I think that might already be, or no, we probably have to hook that up. Yeah. So we don't actually have any checks to run yet. So I think that's what we need to set up next. Just because I think technically what we could do is we could do plugins, Ruby convention check. Yeah. So that's a little bit annoying. So I guess I didn't talk about this. So the syntax is like, you can dig in by project and by build. So we're saying like go into the plugins build, go into the Ruby convention project and run the tests on that. And you can also look at the tasks there. Whenever you see someone running a Gradle command without these colons, it supports a kind of like fuzzy matching. It'll try to find the nearest matching task name amongst all the tasks that exist in all the subprojects. Usually better to be explicit if you can be. So that's what we're running here. But it is convenient. Like usually what I want is I want to just be able to say like, make sure all my plugins are good. So I want to be able to run this command and have that actually do something. So let's define that now. And the way to do that, this is a perfect example of one of those lifecycle tasks where it's like, we already have the task to run the tests we want, right? That already exists. We just want something that pulls it together. And the way to organize lifecycle tests is they should go right next to your settings.gradle in your root build.gradle. So Ruby convention, we're going to make our build.gradle.kts now. Sorry, not in Ruby convention, in plugins. Because we want to define the task at the plugins level. So here's where we're making our build.gradle.kts. And all we're going to define here is that kind of lifecycle task. So here we're going to register a task. And this is like the really simple way to make a task. If you've read build scripts in the wild, you'll often see people registering tons of tasks like this. This is the way to say just make like kind of a blank task that I'm going to customize. Kind of an anti-pattern, according to modern idiomatic Gradle, to do that all the time. You should really be defining like custom task types to do the specific things you want that have like a more restrictive interface for interacting with them, rather than just generating these like blank tasks. But if all you want is a lifecycle task that's aggregating things together, this is perfectly fine. So here, I'm just going to say depends on subprojects map, and then here, I don't know if there's a better way to do this, but we're actually going to do it by name. So we can actually say, we're going to take, so subprojects is built into Gradle, and we're going to say, take our subprojects, map them to whatever subproject name, check. And this check depends on all those checks. And so now I should be able to run that. There we go, successful. So now we have a really easy way to run the tests in our submodule, and not submodule, in our custom plugin subproject. So, yeah, I'm not going to fill this in because really this can be a totally normal unit test now. That's one of the nice things about this is now that we're in unit testing land, you can thankfully stop thinking about Gradle. You can just start, because here we can like call our path lookup function, blah, blah. Oh, shouldn't this be in the package? There we go. Because now it's just like writing a normal unit test. We can do all this stuff, and everything works as you would expect, and you can just write it. So we're going to skip ahead now to a totally different kind of test, which is very fancy and very specific to Gradle, which is, for our case, what we're doing with this Ruby plugin, it's a little bit nuts, right? We're like downloading all these dependencies, saving them in the build directory. We're having like Bundler do a lot of the heavy lifting for us. It would be nice if we could test that too, other than just running it on the command line. Like what if, Bundler changes how it uses config files, or what if we try to specify dependencies in a different way? How do we know that's not going to explode our whole build? And we can actually test that in an automated way with essentially like end-to-end tests for Gradle itself. It's a little bit more involved. I'm going to need to consult my notes for sure, but we're going to go through that now. So what I'm going to do is I'm going to go back to our build.gradle. So this is the build.gradle for the Ruby convention plugin. And we're going to make this much more fancy. We're going to add new types of tests, our functional tests, which are essentially end-to-end. So I'm going to create a new source set. This is a very crazy syntax. I really don't understand the magic of how this works, but essentially this val functional test by source sets creating is saying create a new source set, but it actually is somehow magically like using reflection looking at this variable name. So this is going to not just create a variable called functional test, it's going to create a source set also called functional test. And this is like a blank source set. So if you saw in my last video, source sets have no intrinsic functionality. So Gradle doesn't even know what this source set is yet. It's just a grouping of source files. And so we need to now explain to Gradle what the hell we're doing with this thing. And so we're going to start off by just creating a task that will actually run the tests in here. And I'll call it just functional test. Oh, sorry, need a string for that. So test is a built-in task type. And so we can use that API to do all the things we need to do. So here, the description, we're going to say, run end-to-end functional plugin tests. And this is a new verification group, which is one of the built-in groups. It's nice to reuse those if you can, or if it makes sense to. And so here we're just using, come on, autocomplete test. There we go. Test classes dirs is the output of our source set. So source sets, because we're using Kotlin DSL, I should say source sets do have some functionality imbued to them by Kotlin DSL. Like this classes dirs is coming from there. We can get a class path from the source set as well. These are also going to use our JUnit platform, and this must run after our test. This must run after the normal test task, which was built in. Because if our unit tests aren't passing, we don't even want to bother running these, because these are going to be a lot more heavy duty. And then we want to make sure that our check task runs the functional tests. So we can say that it depends on functional test task. If you're not familiar, it might feel weird, but like test usually means unit test. And so check is run all kinds of tests. So check is going to run test. It's also going to run functional test task. That's the convention in Gradle. And then another one of those magical Gradle things where you just have to tell it what's up. We have to specify separately that this is a test source set. I don't remember exactly why. I just read this in the Gradle docs about this, that it won't work if you don't do that. And then this is where it gets really weird. So just how we did this to include these dependencies for our normal unit tests that are built in, by defining this source set, the Kotlin DSL plugin understands that, okay, since you have this new source set, it can have its own dependencies at implementation and runtime. So we're gonna do that. So functional test implementation and functional test runtime only. And it's gonna yell at us. Because now this is, again, the pain of working with Gradle. Even if we sync, I think it's not going to understand these. Pretty sure. Yeah, it doesn't understand. Because I don't even really know how they resolve this. It's just magic. So basically the Gradle, so the IDE, right, in order to do proper syntax highlighting of this file, needs to finish compiling the file, because in the file is where we're telling it what functional test is, but it can't do that because it doesn't know what functional test is yet. That's why it's complaining. So it's like this, dependency cycle. I don't know how you could resolve this. So they basically didn't. And instead you can use this crazy syntax where you just kind of tell it, to call that by name, I guess. Trust me, it'll be there. And so that'll work. And so now that's all hooked up. And so we can now go back to our source, and I'm just going to be lazy here. Can I just do that? We'll call this functional test. So now we've made our separate source directory, and we're not going to do path lookup test. That's not what we want. We're going to do something much more crazy. And again, I need to consult my notes because this is so nuts. So what we're going to do in here, essentially, is, this isn't even really in the same package. Well, I guess it can be in the package, whatever. Doesn't matter. Doesn't need the package, basically. It doesn't benefit. Oh no, yeah, it shouldn't be in the package. Okay, now I think about it. Boop. Get rid of the package. Because yeah, we're doing a end-to-end test here, where what this test is actually going to do, as crazy as it sounds, is it's going to run a kind of temporary Gradle build using our Gradle plugin. It's essentially going to do just what we did on the command line, but now we're automating it, which is nice. So we're going to instead just call this our Ruby plugin test, because that's what it's doing. It's testing the whole plugin. And we are going to use JUnit, so luckily it saw that import. So again, the magic where it's like, now that the compiler, because we use this syntax, the compiler was actually able to finish parsing this file. So now it understands, like, oh yeah, you do have JUnit available in the functional test source set. So amazingly, it can actually understand how to import it. So I'm gonna just say, like, I don't know, run Ruby, whatever. Naming things is hard. So now what we want to do is we want to create that Gradle build. And we want to do it in, like, we have to, this is where it gets weird. We have to, like, create that Gradle build as if we're, like, you know, how we'd create it on the command line almost. We have to, like, create the files that we need in order to make that Gradle build, which is kind of nuts. So I'm actually going to start off by getting just a temporary directory here. So nothing Gradle specific here. This is just folder. Yeah, that's the one I want. So I'm just using, this is a JUnit thing to get a temporary folder just so we have a clean place to do this test. And so now I can say project build is projector new file build.gradle.kts, right? We're just telling this how to make a Gradle build that uses our plugin. Here we're going to use plugins, and we're going to actually, why even do this? We know exactly what we want to do, which is this. Right? This is what we want to test, like the basic functionality of our plugin. So that defines that, and then we're going to want to run our, wait, what did I call it? Say hello? I already forgot. Say hello. We're going to have to run the say hello task. And now here's where the magic comes in. So we can use this Gradle runner. Bam. So we're going to make one of those. It's a fluent. So we're going to say with the projector, with arguments. So we're going to tell it to, so we created this directory, which has a build.gradle file in it. So we're telling it that's the project you're going to be building. We're telling it to run the say hello task, because that's what's going to test all the functionality we care about. We're going to tell it how to get our plugins, and we're going to tell it to build. So it's actually going to run a Gradle build now. And now we're going to get the result of running that task, and we can do some asserts on that. So we can say, like, okay, sorry, let me import this first. JUnit assert. So we want task outcome maybe task outcome. Okay, I don't know why I wasn't seeing that before. So we're checking that the task did not fail in some way. And we can even be more specific. We can say, like, we know that this should say, what is it? Hello world. So let's get that. Sure. So we're going to say, like, unexpected output, task output. Oh, wait, why did I call this task? Oh, no, yeah, sorry. So that gets the task, sorry. So result is the result of actually running the Gradle build. Task is just like if you want to like get specific information about that task situation. I don't know how much you can do with that. You can really just get the outcome. But we can just kind of like, using a hammer a little bit, we can just like assert on the overall result output with few too many U's. And here we want to assert true that result output contains hello world. I think that's what we want. So that is a functional test. Hopefully it's a functioning functional test. So now if we run plugins check, ooh, running the functional test. So these are very slow, as you can see, but it passed. Woo! So here, let's just see it fail, just so we can prove that it's actually working. So yeah, functional tests are extremely slow, but you know it's much better than nothing because it is running a full Gradle build, and so okay, it did fail, which is what we wanted. And so you can see, oh nice, get to see what other stuff I'm working on. So, you know, you get the normal JUnit output, so you can see here it says, has the full output, said hello world, and right, because we said unexpected output, so you can see that it did not say goodbye world. So that's that. Yeah, and that's basically everything that I wanted to show you, how to make Gradle do some crazy stuff. So, you know, there's a lot of different places you could take this. Like you could specify, it wouldn't be that hard to specify like Ruby scripts in here that you want it to run. Like also worth noting that like, you know, these, because we included the plugin, right, all these types are available right here as well. So like you're not restricted to abstracting everything away into the custom plugin. Like you could also just say, okay, the plugin defines the task types, and now in your Gradle build, now I can tell, you know, my project how to run whatever Ruby scripts it wants to run. So you have a ton of flexibility in terms of how you want to actually use these techniques in your code. And if you haven't watched it yet, you should really watch my other video about how to do this, or how to understand Gradle in general, modern Gradle. And I'll also have in the description a link to a GitHub repository with all this example code if you'd rather check it out that way. Thanks.